All right, so here's a question for you. Conceptual type question. We'll solve it all the way to the end too. So a car sits at rest at the top of a hill. A small push sends it rolling down the hill. After its height has dropped 5 meters, so it's dropped down 5 meters, it's moving at some good clip. Write down the equation for conservation of energy, noting where's the beginning and the end. You could solve this problem using the information you already have. You're in physics land. We are in physics land with this problem. You could use write down the information and solve it. Well, there's my picture. There's my car at the beginning. There's my car at the end. What is the information? What do I need to do? Well, VI is 0 meters per second, right? How do I know that? Because the car is at rest. I come down here, my V final, that's unknown to me. Let's assume the height of the hill is 5 meters. Where did I get that number from? I'm just making that assumption. I don't have to make that assumption, but in this case we're going to. Because we're going to say the bottom where we care about is down 5 meters from the top of the hill, right? Question says it's gone down 5 meters. How fast is it going? That's the bottom as far as we're concerned. Could be greater, could be less. Doesn't really matter. Write down the equation for conservation of energy. Well, what's the very first thing we need to write down? E sub I equals E sub F. There's your equation. Okay, now let's fill it out a little bit more. Just like we did with momentum. Kinetic at initial plus potential initial. It's got to equal kinetic at final plus potential energy final. Let me emphasize, don't be lazy. Write these down, write it out so you don't make careless mistakes. Well, what is kinetic energy? That's 1/2 mv initial squared plus mgh initial equals 1/2 mv final squared plus mgh final. Right? Now, you write that out. Now pause and think. What is 0? What is not 0? What do I know? What is it that I'm looking for? You're jumping ahead of me, but notice. M's all go away. This will be example number 5 or 6 where, what's pulling this thing down the hill? Just a second. What's pulling it down the hill? Gravity, right? Does gravity care about the mass of the object? No. This is going to be another example of it. You had a question? Initial velocity is 0. So this whole thing here goes to 0 for us. What else is 0? The final h, right? The final h is 0. Because we're saying bottom of our hill. That's our bottom. That's where we care about. We don't care. So this simplifies down to, we rewrite it, GH initial equals 1/2 V final squared. Right? That equation just simplifies right down. If I do my algebra first before I plug numbers in, it becomes much easier. What am I looking for in this case? What is the question asking you for? Write down the final states. Really, it's asking you, how fast is it going, right? Going at a good clip. What does that mean? What is it? If I was to add a little thing, how fast is it actually going? You're solving for V final. Well, V final is going to be 2GH all square rooted. Over this one right here? Yeah, why does that MGH cancel out? Because my H final is 0. I'm at the bottom of where I care about. Right? Now, if I gave you more information, I said you're halfway down the hill at that point in time, then that H final, I would have to decide where did I put my 0 and plug some numbers in. But for us, questions on that? If you plug those numbers in, let me see if I actually did. You plug those numbers in, grind it out, you're going to find that the final velocity is 9.9 meters per second. So it's going 9.9 meters per second. Gravity is what pulled it down the hill. Gravity doesn't care about mass. Another example of where mass of the object doesn't matter. So you're going to get examples, homework problems. You're going to get questions on the exam where I give you the mass of the car or don't give you the mass of the car. In this kind of a situation, it's irrelevant. Doesn't matter. Don't need that information. And if you do the algebra first before you plug the numbers in, that is a very simple equation to plug into your calculator, right? You make less mistakes. Questions? Why doesn't G cancel out? Good question. If you go back to this original equation here, what do I notice here? The only thing that can cancel out is something that every piece of the equation holds. So if I look, I got 1/2 mv squared, there's no G in that, so I can't cancel G. I can only cancel things that it's the same everywhere across. Does that make sense? Any other questions? Good question.